I'm Jess Kozman, and I'm here with my colleague Debasis Chatterjee from
Hello.
Katalyst Data Management. And we're going to give you a quick overview of some of the work that we have been doing with OSDU, specifically for the mining industry. And what I want you to be thinking about is how are there uses for some of what we're doing in this space that will come back and assist some of the workflows that you have in whatever data type you're working for. And who do you know in the mining industry that may benefit from knowing about what we're doing here at OSDU? So I'm going to start out by talking about some of the common needs that drove our interest and the mining industry's interest in OSDU, what that overlap looks like on the platform, and then Debasis is going to walk you through an application that we've been building specifically to service mining data. So I've been asked to kind of set the business context for this, right? Why would a company that specializes in oil and gas data management go over to the mining industry and start actively soliciting companies to work with the open source data platform with OSDU? And there's a little bit of history behind that and a little bit of happenstance, people being in the right place at the right time. And we'll talk about that, and we'll talk about some of the interest that has been generated, and then a summary of some of the common data types that probably come to mind when you think about it, and maybe some that don't. So my work with OSDU in the mining industry started a few years ago when we jointly with a service provider in Australia, when I was working there, presented the idea of using OSDU as a repository for data for an accelerator program in the early stages of mining exploration. And it seemed like a really good fit. That didn't come to total fruition, but it allowed us to look at the data types and the schemas and make an initial finding that a lot of the data types that were being used were, as you would expect, especially in the mineral exploration part of the mining life cycle, were common across the two industries. We were also positioned in Perth, Western Australia at the time, which is kind of unique in the fact that the oil and gas industry and the mining industry literally almost cohabitate, right? Perth is a relatively small city. All the big companies there are literally across the street from each other. Anytime there's one of those asset, commodity, pricing cycles, everybody just moves across the street between the oil and gas industry and the mining industry. So there's a lot of cross-fertilization of skill sets and understanding of data management best principles. So that history took place at a time when we at Katalyst were developing a search and order portal for the OSDU platform. And we took a quick look at that and said, look, some of these data types are very similar, geology and geophysics, subsurface measurements. We've already got some expandable metadata links that we can use. The mining industry are looking at, in a lot of cases, moving from on-prem solutions to cloud destinations. And they were looking for a portal where they could output data in a format that it could get into their integrated interpretation and analysis programs. So it sounded a lot like oil and gas. So we took off with that. We helped start the mining special interest group within the OSDU community. We set up a community in Western Australia. And if you look at the participants in the mining SIG Slack channel today, you'll see a lot of companies represented there, including the cloud service providers, operators, and application providers. So, and a lot of those discussions are ongoing with additional companies that are starting to hear about applications in the mining industry and starting to ask questions. What is OSDU all about? How do we use it for our data types? The most obvious conversation to have between oil and gas and mining is about the overlap of data, right? So when we talk about OSDU as being a platform that allows you to manage physical measurements of rock properties at a specific point at a hole in the ground, the mining industry goes, oh, that sounds a lot like what we do, right? They may talk about it differently. They may use different terminology, but the basic concepts are the same. And on this diagram, we've just kind of outlined some of the obvious areas where data types overlap between oil and gas and the mining industry. And you can look at the ones that aren't highlighted and think of ways that the data might overlap as well. But these are the areas that we're focused on and concentrating on at the behest of our current mining operators that are working with us. So from a vendor point, so that's the operator's point of view, right? You've got a platform that's already got some things developed. We don't need to reinvent the wheel if we want to work with our subsurface digital data. From a vendor point of view, I think it's important for you to understand that because we're able to reuse some of the open source code that's already available in OSDU, we can deliver faster for this industry segment, right? We can get to their endpoint of deliverable data and value faster, which means we can engage with more customers, right? So for us, it's a business opportunity and an area where we can apply best practices that we're already enabling and working with in the other sector. And we can add additional services, right, for clients that may be working both sides of that. So when we think traditional hard rock, igneous rock mining, we're thinking about the subsurface measurements, but now we're starting to talk to companies that may be doing in situ solution mining for critical minerals like lithium or uranium, who have a lot of borehole data. They may not be exploring, they may not be tunneling or open pit mining, but they're a mining operation that's using, in some cases, a reused oil and gas borehole. So there's even a lot more overlap than there was maybe a year and a half or 2 years ago. And of course, we're leveraging all of the in-house expertise that we've already set up to service our oil and gas clients. So we're going to look at a particular use case and what we can offer by putting a portal on top of the OSDU platform, and Debasis is going to walk you through that.
Can you all hear me? Okay, thank you. Yes, so thank you, Jess, for starting the business introduction. We're going to show you some more technical details about how we can get the both worlds to meet. So OSDU data platform at a glance, we'll just show you a quick picture. We won't stay on that for too long. It's an architecture picture, which I often use, and we'll show with a tick mark, which are potential areas of overlap between the two industries. And I wanted to remind ourselves that the name OSDU has changed over time, as you all know. It was called Open Subsurface Data Universe. Now we don't use that because we opened up to new energy and many other different things. And the question what we ask when we are debating about whether to use OSDU data platform for mining is, why reinvent the wheel? Do not start from scratch. We want to leverage whatever we can. And if there is a need to adapt to mining terminology, there is a chance and potential to handle that in the user interface. Underlying data can be sharing the same schema between oil and gas and mining, but your interface can speak the mining language. That's possible. My colleague calls it, I think, mining skin, okay? And we'll also find there are gaps. As we start to work with an existing schema for mining geotechnical data or technical data, then you'll find there are some gaps, but let's work together. So whatever improvement we bring in, it'll help both worlds, oil and gas world and the mining industry, right? So this is a picture I have been attempting over the years to put the OSDU architecture in one pager. Don't worry about getting the details. Simply look at the tick marks, which tells you which are the potential areas where mining industry can benefit from what is already existing, instead of trying to reinvent the wheel and starting from square one or scratch, okay? So again, I'm going to touch upon those tick mark areas into little more details you will see over the next few slides. So recap of the touch points, just a few examples. So one example is the mining. They have the downhole survey when there is a hole, of course. And in the oil and gas world, in the OSDU speak, we call it wellbore trajectory. And that's well handled by wellbore DDMS. So why leave it in the site? Let's make use of it. Rock sample. In the mining industry, just like the oil and gas, they have the downhole and the surface sample. And rock and fluid sample DDMS, excellent contribution by ExxonMobil, EPAM, joint development that's evolved over the years. And let's make use of that. Core image photo, that's not new in the oil and gas world, same thing. All different kinds of analysis. The rock and fluid sample DDMS deals with, if I remember correctly, 40 plus analysis types. And many of them are sweet spots. They just match up. You want to take about XRF? Sure, it's there already, right? So let's make use of that. The grid data handling. I've heard interesting discussions between our good friends from Aspen Tech and the mining industry people saying, there is a good fit about grid data handling in the reservoir DDMS. Again, let's make use of it. If there is ground seismic data, of course, it's no-brainer because seismic 2D and 3D in the oil and gas world is very nicely handled, very mature coverage in OSDU data platform, and again, it can benefit from that. I heard the new term when I started to deal with mining industry data is the plod, which is probably more common in Australia. It's for the drilling operations data. So whatever exists in the oil and gas world, there is no problem. It's a total fit. General tabular data. So OSDU schema has something called Columbus table that can handle general tabular data. Spatial data, whatever our good friends from ESRI and other contributors building in the geospatial consumption zone, why not adopt that for spatial data in the mining world? My mining clients throw towards me all kinds of fault and fold and contact, and I always think this is a great fit. We can handle it with the geospatial consumption zone. And consumption of public data, that's another use case we started to think about. EDS is there, out there for grab. Let's try to see if EDS is a good fit for grabbing public mining data from different sources. Okay? So that's an example what we try to build a flexible portal, we call it OSDU GeoPost, and using a template approach. So what happens there, power user will build a template, and that can be consumed by n number of end users. So in the template, we can change what I was calling earlier the mining skin. If the mining industry don't like the word wellbore, they want to hear something else, drill hole, we can change it here in the interface. And in the interface, as we heard in many other presentations, the JSON nesting and array and all of those things are very good, very flexible for the database, those technical gurus. But for the end user, they like to see the data flattened. So all those things we can handle in this when we are building the template, right? So that's just one example. So one example I wanted to bring here about the synergy, about the touch points, data model, the collar versus the drill hole in the mining world. There is tremendous synergy with the oil and gas well and wellbore. Well is in the surface, wellbore is going in the ground. And again, I said before, manage the user presentation with the flexible design and manage extra fields using sidecar. And the sidecar approach is not new in OSDU. It was already used in the well delivery DDMS when that was active. So, and why we have to do this approach is because wellbore, if I want to use wellbore DDMS, I have to keep the term wellbore. So hence, there is a need to have this approach. Very similarly, sample, if you want to use rock and fluid sample, let's do with the sample schema, because that's used time and again in the rock and fluid sample DDMS. Okay? So I just put a picture like that. So the collar in the mining world matches with the well, drill hole with the wellbore, downhole survey with the wellbore trajectory. Okay? Sidecar, one example. I'm trying to show the well-known schema wellbore, and you put a sidecar for the mining industry. But in the discovery portal, what you present back to the end user, you combine the things, present a combined view to the end user. End user won't know that we have utilized part of the well-known schema and some part in a custom, maybe it's custom temporarily. Maybe over time, it will become, if the mining industry, they get together, they work, and they can just make it another well-known schema. That's fine, too. So I can see some list of enhancement required. So supporting new analysis types in rock and fluid sample DDMS and allow some flexibility for mining assay data. And this is a common need. We heard time and again from many presentations. We need proper guideline, working examples for many different data types. Grid data is one of them. Gravity magnetic data model just started in OSDU, and that can be completed with a joint effort from both industries, right? And I would say get inputs from mining community, as Jenny is already doing as she's building the reference data for rock and fluid sample world. She's already reaching out to multiple players, and both sides can benefit and enhance the existing schema. In some cases, the sample image to fit the mining industry's needs a little more. So some enhancements are needed. And I would say when someone is thinking about using in this way, this approach, think about a discovery portal which has to offer a tabular view of data, and again, a map view for all the point and polygon and lines, And map view, again, use geospatial consumption zone if you can. Think about for the photographs, core photo, all of that, some photo gallery. Or very often people will say, provide me a link to the external, another application which is very good in handling and showing the core images. That's possible. And very often what another need will be combined vertical view, where multiple depth-based data, which is very common in the mining industry, alteration, vein, and many other examples can come, and export capability. These are kind of common needs one has to keep in mind if you are taking this approach. And yeah, this is just an example of showing the core photo. And if I'm lucky today, and I think Jody confirmed this will work. So here we're just showing the approach of building a template. The power user will build a template, starting up with OSDU schema, what particular partition where your data is lying. And in the template building approach, they will take the schema, and a schema will have, thanks to our data modelers, they have designed a schema with 50 or 100 fields. And many of them, we can just start up by saying, I don't need any of that, and I'm going to take only 5 things or 10 things, right? So that's the approach we'll take. And those are buttons which will bring the object on the map, whether it's a point object like a drill hole, whether it's a polygon or something else, some kind of geological data. And yeah, in that with the star, with the gear button, we are going to build the template, meaning just select the fields which you want to appear in the table view, remove everything else, change the heading if you need. I think it's going a bit slow for some reason. Is that the video has been a common problem? And no, what it's yeah. So it shows you the tabular view where some of you who are deep into the OSDU data platform, you heard about augmented index approach that was offered to flatten, because very often you want to flatten the data, although in the database it's lying as a nested or array of multiple elements. So all those things have been introduced when building the template. So user will simply get a view like this. In addition, for some of the data types, user can go in, and if the proper viewing is enabled, like a core view, what I showed earlier, or if it's a log, petrophysical log, and if you happen to have seismic data, 2D, 3D, the portal will offer you those kind of viewing capability. It's not unlimited. It's limited to some of them which we have incorporated the viewing capability. So again, limited to the well log, the seismic 2D, 3D, and the core image for the time being. And again, as we work with our clients, as we start to see their needs growing, we are going to introduce more and more things, right? So that's the kind of one example of how we have done. We have worked with 1 or 2 mining clients, put their mining technical data inside OSDU with this approach. That means try to utilize well-known schema as much as possible, try to utilize the features, different DDMS, what they offered, the wellbore, the rock and fluid, and reservoir for grid, etc., so that we are leveraging what OSDU, this forum, is offering, and which they have built over multiple years of R&D. So I'll just wait for this one to finish, and then, yeah, it's going a bit slow.
And while that's running, I think it's worth pointing out that this application has been developed, as Debasis mentioned, with input from some of our key mining clients. And if you're thinking about mining data and thinking it may not have the same scale and breadth as some of the things, the data types that we need to use in oil and gas, I think I'm on good ground here mentioning that with our first mining client, which was BHP Minerals, who you've heard from at several forum presentations now, both here and over in Amsterdam. We're approaching the point now where we have, with our partners and allies, we've loaded close to 1 million boreholes from the mining industry into their OSDU platform. So we're also able to demonstrate that not only are we able to spread across data types, but we can work at the scale that's expected on the cloud. So.
Sure. Yeah, I think it's going a bit slow, the speed-wise, so I'm afraid we are... Yeah. How are you doing on time, Justin?
We still have 10 minutes, so...
yeah, sure.
Yeah, would you like us to stop the video?
Yeah, I'll let it finish. Yeah, so this is where we are building the template. Is very important. As I said, that well-known schema will give you a long list of fields. We start up by saying disable everything, only show me the ones I need, and change the header. So on the fly, header is changed. And one thing to add here, I forgot to mention that we are not duplicating the data anywhere. All the conversions, transformations I said, like changing the column header, flattening the data, everything happening on the fly. When the data is being presented back to the end user, there is only single copy of the data in the OSDU data platform. Okay? So the portal, as it extracts the data from the OSDU data platform, using the standard core services, it applies these transformations before it is presenting back to the end user. In the, as I said, the table view, map view, whichever way you want to look at it. The demo, the short demo here is only covering few data types, but you get the general idea about how we can approach the same mechanism. Yeah, it's just showing few schemas of wellbore and seismic acquisition survey, but you can have a long list of schemas listed in your template, and you start to visualize multiple things, multiple data objects on your table view and on the map. Okay. So I think we can bring it to Jody. If you can please advance that to the, we probably don't need the, yes. So I think I didn't want you to be waiting. I know we are running late already. So we can take up questions at this point. Thank you.
Thank you. Can we show our appreciation? We do have a few minutes for questions. Are there any questions, please?
There have to be a few.
I was asking a question earlier. I'm at the other end now, please.
Okay, sir. Thank you. 1 second.
Thank you. Hi, Debasis on the front here, Bert Campus from Shell. It looks very similar in the architecture, like to how the geospatial consumption zone is set up in a way that you can have a feature class and you can rename the title and you can select which attributes you want to show. Is there any overlap or merging those two approaches at some point?
Yeah, no, thank you for that question. But the way geospatial consumption zone has the approach, as you know, it gets the data from OSDU data platform. And I think there is in the room some more experts who can correct me. They bring the data to Apache Ignite as a cache, okay? Selective data types. They bring it to Apache Ignite, and through COOP, they are enabling that map visualization, right? So with our mining client, we tried that same approach with some set of spatial data, whether it's geology, bedrock, on fault, or contact, or anything like that. So we tried that, but what I showed you here is on the base core platform. This one is not utilizing geospatial consumption zone. And as I mentioned earlier, we are not building another cache. It's keeping one copy of the data in the platform, and it's doing all the transformation, which I was trying to show, flattening and everything on the fly. Okay. So there is some synergy, and we are trying to utilize that in our implementation, geospatial consumption zone, where it makes sense. But for the basic data like drill hole and the wellbore equivalent of that, presenting that with the metadata or any other analysis, we are not using the geospatial consumption.
We're also sidestepping a workflow that we've seen with some of the mining clients where there's a geospatial data discovery tool that may require taking the data and indexing it in Solar or something. And we're trying to avoid that duplication of data and that extra step in the workflow.
Thank you for the question.
Thank you. As we had discussed before, Troy from Chevron, is any of that in the background use of EDS? Is anything of EDS in that interface behind the scenes?
No, this is designed specifically to be cloud storage agnostic and technology vendor agnostic. So this would be a portal that you could put on top of an OSDU platform no matter where it's running on the cloud, it would work with the community implementation or any other current cloud service provider.
I'll add to that, to Troy's question. Thank you for that question, Troy. Is the EDS part, as I mentioned earlier, please come and join the 2 o'clock presentation. We have a presentation about EDS. That's getting data from external. I mentioned EDS in our talk here today to say there is potential for mining industry to think of. If they're using OSDU data platform, use the EDS as a ETL technology to bring data from perhaps public data sources. Set up that ETL pipeline so your data from whatever government site you are trying to bring in to have some public data, you can arrange that. So with one of my clients, we did some POC, but it's not yet implemented in full scale anywhere, right? But we tried out EDS for that use case, not in what I showed. What I showed, the Katalyst developed portal application, it's sitting on top of the native OSDU data platform, using the core services, using few other features like DDMS and whatnot. Yes. Other questions? Sorry. That'll be a difficult question, sorry.
No, how are you handling the dictionary, like the definitions and the reference data in mining?
Yes. So good question, Shashi. The answer to that is, I was trying to show briefly in the demo that power user will build a template to get all the schema fields from all different schema, one or more, right? And give the new name which is befitting to the mining industry. And so template de facto is that schema, you can say. And that schema can be derived from one single schema of OSDU, or as I showed one example with a sidecar, because all the well-known schema offering was not enough for the mining industry's need. So we had to add an additional sidecar, okay? And that sidecar today is custom, but our hope is when they get together, the different mining operators and vendors, perhaps they can work together to promote this from custom to well-known schema over time. Okay? So de facto, that is the way, Shashi, that we are managing the power user build template to be the schema. Okay? Thank you for the question.
Thank you. Was there one more? We do have 2 more minutes if you want to.
Okay.
Thank you.
Okay. So my question has to do with, I'm talking from the government perspective. You are now going across two different areas. Mm-hmm. So how do you handle data custody across the areas? Thank you.
Good question. Thank you for that question. So as we said that we tried to leverage OSDU data platform, which was initially built for oil and gas world, extending to mining, and there are more people sitting here, new energy representing and all of that. So it's going to extend to more, right? So from government point of view, I'm going to request you one thing, is there is a work group called Regulatory and Compliance that is mostly to deal with NDR, government agencies, regulatory, both Jess and I. Scott Kimbleton leads that session with few others. Please join that and let's work together to see how we can manage that. But we also see, we don't see any problem in this convergence because you're saying in the same platform, you'll have oil and gas data, you'll have mining data, and you'll have to manage to differentiate them with proper tagging and proper flagging. So I think the details of that, let's work out together because that is an active work group called Regulatory and Compliance. We meet now, I think, every alternate week.
Correct.
Every alternate week, you find us in the aggregate calendar. Scott, who's in the room, may not be in this room now, but he's leading that work group. A few of us are actively engaged. So we can work out the details in that side work group discussions.
Yeah, and if the question is addressing, for instance, national regulators that have restrictions on data remaining data sovereignty within a particular geographic boundary, we've already demonstrated through an MVP in the regulatory that we can handle that with the legal tags and the location of the data within regulatory restrictions. So.
Excellent. Thank you so much. Please show your appreciation.
All right.
Thank you.
Thank you.